Hello, everyone, and welcome back to your channel of Math Made Easy. What I would like to do today is to go over different ways of solving quadratic equation. What we are going to learn today is how to solve it using factoring or using completing the square, or as a last resort, you use the quadratic formula. So in this case, I prepared like three problems. This one, when you look at it, we want to factor that. We know that, first of all, the first thing you notice is that I have x here and x here. That's how you get x squared, right? And then because this is negative, negative has to be positive on one side and negative on the other, right? Because if they are both negative or both positive, when you multiply them, you will get a positive constant. We refer to the coefficient of x squared as a. So a here is 1. The coefficient of x is b, so b is 10. And the coefficient of c is the constant, which is negative 24. We are looking at two numbers. Their product is a times c, but since a is 1, I want them to, when I multiply, I get negative 24. And when I add them, the sum, I get b, which is 10. Notice the sum is positive, so I need to have two numbers to multiply to 24. One of them is negative, one is positive, but I want the positive to be the larger, because when I add them up, I ended up with 10, not negative 10. If that was a negative 10, I would say the bigger should be negative. Now let's see what 24 is. Of course, many of you already know the answer, but we can, the worst case scenario, I can say 24 times 1. Forget about the signs now. And because the product is negative, I'm not looking really at the sum, I'm looking at the difference. Because sum and difference is the same thing. If you add a negative value, then you are summing two values instead of subtracting. So don't get confused with the nomenclature. This is sum or difference. If that's a negative, I'm looking at the difference. If that's a positive, I'm looking at the sum. Okay, so I want two numbers. Their difference is 10, the bigger being positive and the smaller being negative, and their product is 24. Forget about the signs for now. And 24 minus 1 is 23. I want it to be smaller, so I have to get them closer to each other. Of course, instead of 1, if I make that a 2, that would be 12 times 2. The difference is 10. Bingo, I'm done. So the 12 is the positive because it's larger. So that's 12 and negative 2. So 12, negative 2. I'm done. So really when a is 1, it becomes easy. And here you say either x equals negative 12, if x plus 12 is 0. When you multiply two things and get 0, it's either the first is 0 or the second is 0 or both. But they cannot both be 0 since one is I add to it 12 and the other I subtracted 2. So how come both would be the same? Either this is 0, in which case x is negative 12, or this is 0, for which x equals 2. And here it is. Now, suppose I entered 6 and 4 because they add up to 10. So I forgot, I said the sum, so I entered plus 6 plus 4, for example. How do I check my answer? When I was your age, like a middle schooler or something, we didn't have calculators. The calculator started, well, I got my first one, I think, in as a freshman in college, or maybe senior in high school. I think it as a freshman in college. So at the time, I had to check my answer. I want to know if this is correct or no. So the quickest way I used to do, and it still works till now, I mean, you can use it, it's very nice, as you will see. I assume x is 10, and you say, why 10? I said, because if you tell me x squared, it's 100. There is no reason I multiply anything. If you say 5x, it's 50. So it's easy to say x squared is 100. And 10x is another 100, right? Because 10 times 10. So that's 200. And then you subtract 24, so you get 176. 100 plus 100 minus 20 is 180, minus 4 is 176. Now, x plus 12, if x is 10, this would be 22. X minus 2 is 8. 8 times 2 is 16. 6 and you carry over 1. 8 times 2 is 16 and 117. Bingo. I know my answer is correct. See, very simple. I just thought of it and I was working using it, and I was afraid to tell my teacher or something and say, no, no, this is wrong. And I said, okay, it's working for me, so I'm going to use it. And of course, later I learned, of course, it's correct. Okay, that's one way. The other method is called completing the squares. If you know one of them, that's enough. But in school, they usually ask you, oh, solve this one using completing the square. Okay, I will, but doesn't matter. In completing the squares, and I think I did that in my other session where I was not comparing, but wanted you to see algebra versus graphing. So you draw a parabola and then you understand what it means a solution, what it means axis of symmetry and stuff like that. Anyway, if you haven't watched that, here it is again. I'm going to enter the x square and the 10x. So the stuff that has x only between parentheses, I'm going to close the parentheses and leave a blank. And then say minus 24 equals 0 if I you say equal, or you can say equals 24. It really doesn't matter. So minus 24 equals 0. I didn't do anything except using parentheses. I want to make that a perfect square. How do I do that? Very simple. You divide the middle number by 2, so you get 5, and then you square it, you get positive 25. So no matter what you do, it's always going to be positive. But when you add 25, you must subtract 25 or else you have changed the problem. Okay? Now the quantity between parentheses without thinking, when I divided this by 2, I got plus 5. So it's x plus 5 squared. And 24 and 25 is 49. Minus 49 equals 0. And you can see that 49 is a perfect square. It's 7 square. So I write minus 7 square equals 0. You should have learned in algebra that a square minus b square equals a minus b times a plus b. So a is x plus 5, b is 7. So I say x plus 5 plus 7 times x plus 5 minus 7 equals x plus 12 times x minus 2. Sure enough, x plus 12, x minus 2. And that, again, how easy it is. Finally, the third method, which is a guaranteed to work in all cases, is because sometimes you cannot factor, but you can always do that. Notice we said ABC, and you should know that we can say x equals negative b plus or minus the square root of the discriminant. What is the discriminant? It's b squared minus 4ac. If that value is positive, excuse me, you get two roots. Negative 12 and 2 is a case. I didn't solve because we already did it. You don't need to waste time. You get two roots. If it's 0, you get one root. And if it's negative, you get two complex roots, meaning it has a real portion and an imaginary portion. So you can check from the get-go. You already know we have positive because we ended up with two roots, but you can check out. You can say b squared is 100. minus 4ac, but c is negative, so negative times negative is positive, so you already know that b squared, I'm sorry, minus 4ac over twice a. But since c is negative, then this quantity would be positive under the radical, meaning you will end up with two values. Negative 10 plus or minus the square root of b squared is 100 minus 4a is 1, so still minus 4 times negative 24 is positive 96 over twice a, and since a is 1, you simply divide by 1. This becomes negative 10 plus or minus the square root of 196 over 2 equals negative 10 plus or minus 14 over 2. So it equals negative 10 plus 14 over 2 or negative 10 minus 14 over 2 equals 4 over 2, negative 24 over 2. Notice that it gives you the answer right away. It doesn't give you what goes inside, but it gives you the answer negative 12 and positive 2, like before. And that's the first example. It was easy because a is 1. So I picked another one where a is not 1. Okay? In this case, we have a is 2, b is... So when I want to factor those, sure enough, I will have 2x in one and x in the other. That's the only way you get 2x squared. And I know that one of these is positive and the other is negative because when I multiply them, I get... In fact, I don't get... Yeah, I get a negative value. Okay. Now, we see I need two numbers such that their products is a times c. A is 2. So 2 times negative 20 is negative 40. So one is positive, one is negative again. And their sum is 3. So the bigger is positive. Okay, so that's the bigger is positive. So I subtract two numbers, but their sum is positive. Okay. So as we did last time, if I say 40 and 1, the difference is 39, too big. If I divide by 2, so I get 20 and 2, 20 times 2 is 40, difference is 18, still big. If I make that 10 and 4, the difference is 6, still big. And sure enough, if I make 8 and 5, the difference is 3, so 8 and 5. But how do I write that? That's a little tricky. Notice that I want the bigger to be positive. So this is positive and this is negative. And notice that the 2 would be multiplied by this constant and the 1 is multiplied by that constant, right? Now, I cannot get in 5 or negative 5 by multiplying 2 by something. So that cannot be the negative 5. That must be the positive 4. So that when I multiply 2 by 4, I get 8x. Again, I couldn't write the 5 here because this 5 would be multiplied by the 2. And if I do, I get a 10, not an 8. The only way to get an 8, because it's an even number, I have to multiply 2 by 4. Someone would say, oh, why don't you multiply 8 by 1? Again, I cannot get a 5 by multiplying 2 by something. So that must be negative 5, and that must be positive 4. Or else, I can never get 8x and negative 5x. You see? Equals 0. So either 2x minus 5 equals 0, or 2x equals 5, or x equals 5 halves, or x plus 4 equals 0, or x equals negative 4. Like we did before, Is this correct? How do I check? The method I told you. X squared is 100 times 2 is 200. 30, 230 minus 20 is 210. 2x minus 5 is 15. X plus 4 is 14. 14 times 15 is 210. You can check your answer with a calculator. You can say 15 times 14, and sure enough, it's 210. So you can check your answer very quick. Nice? Okay. Now, second method is completing the square. When I do completion of squares, I prefer to make that x squared. Some people will tell you multiply the whole thing by 2 and make that 4x squared because that's 2x quantity square. Yes, you can. But what I'm going to show you is I'm going to factor the 2 and write this as x squared plus 3 halves x. Okay, I factor 2 to make that x squared so I can fill in or complete the square easily. Leave a blank, minus 20 equals 0. Remember, we divide this by 2, so it becomes 3 over 4. And then we square it. It becomes 9 over 16. And some people would say, oh, I added 9 over 16, so I subtract. I did not add 9 over 16. You don't ever forget. Every time you factor something, be very alert. I added 9/8. 2 over 16 is 8, right? 1 over 8. So I subtract 9 over 8. This is extremely important. Now, I know that this guy is x plus 3/4 square. How did I know? Because when I divide this by 2, I get 3/4. So you don't need to check. Minus, I'm going to take a common denominator of 8. 8 times negative, or 8 times 20 is 160 plus 9 is 1. Notice I took the negative out. So this is like 20 plus 9/8. Factor the 8. 8 times 20 is 160 plus 9 is 169 equals 0. I'm going to simplify by dividing by 2 and moving this to the other side if you wish, or you don't have to, just leave it. So that becomes x plus 3/4 square minus 169 over 16 equals 0. Like we did in the first problem, that becomes x plus 3/4 square minus 13 over 4 square equals 0. 13 square is 169. 4 square is 16. Okay. So now a square minus b square is a plus b times a minus b. 3 and 13 is 16. Over 4 is 4, so x plus 4. Yeah, x plus 4. And this guy becomes x minus 10 over 4, so x minus 5 over 2 equals 0. That's another way. Notice because we divided by 2, that's why we got the answer right away. X equals negative 4 or x equals positive 5 halves. That's completing the square. And finally, using the quadratic formula, we say x equals negative b, meaning negative 3, plus or minus the square root of 3 square, minus, but there is another negative, so plus 4 times 2 is 8 times 20 is 160. Notice that's the 169 here. Over twice a, meaning over 4, because a is 2. We don't always divide by 2 like I see some students do. Be careful. So you get negative 3 plus or minus the square root of 169. To save time, we say plus 13 over 4 equals Negative 3 plus 13 is positive 10 over 4 is 5 halves. Or x equals negative 3 minus 13. We already did that. Negative 16 over 4 is negative 4. Okay? Sometimes that will not be a perfect square, so you end up with two non-rational answers, like plus or minus square root of something. Okay? One last one, and I will stop. So in this one, we have x squared plus 14x plus 65. So again, we need two numbers that their product is 65 and their sum is 14. And you say, this is impossible. Right there, you can stop and say, why? Because 65 is only divisible by, it's 5 times 13. There is nothing else. Or 65 times 1. It's not divisible by 2. It's not divisible by 3. It's not divisible by 4. It's divisible by 5. So you either say 65 and 1, and their sum is 66. That's much higher than 14. So you say, okay, so let me divide this by 5 and get 13 and multiply that by 5 and get 5. They add up to 18, which is more than 14. So no, I cannot factor. So factoring doesn't work. I told you sometimes you cannot factor. So in this case, I'm going to complete the square. X squared plus 14x plus 65 equals 0. I'm going to divide this by 2. I get 7. Square it, I get 49. I added 49, so let me subtract 49. This would be x plus 7 squared. Again, I divided 14, positive 14 by 2. I got positive 7, so no check. I already used it to complete the square. 65 minus 49 is 16. So if I move 16 to the, I cannot, well, we can. I think I showed you how to factor the sum of two squares. But if you didn't see that, it's okay. I can say equals negative 16. Then I'm going to take the square root of both sides. Left-hand side becomes x plus 7 because the square and the square root cancel. The right-hand side, you notice root of negative 16 is the square root of negative 1 times the square root of 16. And I have to say plus or minus because we take the square root. We have two answers. Okay? We call that I, you know that. And the square root of 16 is 4. So plus or minus 4i. So x equals 7. Oh, I'm sorry, negative 7 because you're going to subtract 7 from plus 4i, or x equals negative 7 minus 4i. That's completing the square. Or you can use the quadratic equation, x equals negative b plus or minus the square root of b squared, which is 196, minus 4 times 65 is 260 over twice a, equals negative 14 plus or minus the square root of negative 64 over 2, equals negative 14 plus or minus 8i, because that is the square root of negative 1 times the square root of 64. Square root of 64 is 8, square root of negative 1 is I, over 2. You can simplify by 2, so you get negative 7 plus or minus 4i, which is that. So I hope this was easy enough. And this one always works Completing the square also works. So if you don't end up with a perfect square, you will only end up with either, if it's negative, you will end up with a complex roots, or if it's positive but not a perfect square, you will end up with irrational solutions. And they always come in pairs, okay, plus or minus. And that's basically it for today. I hope it was an easy and short one, and it maybe clarified some of misconceptions or explained something that you didn't know. If not, then sorry for wasting your time. Have a great time and hope to see you soon. Bye.